we're back. I'm not sure if you ever left. Anyway, I wanted to keep playing around with this example where a professor is picking some students out of a class to work together on a project of some sort, but I do want to mix things up a bit. So far we've been looking at pairs of students. I'm going to change that, and instead of picking out a group of 2, we're going to grab a group of 4. So that gives us a little more, possibility space, I suppose, if you wanted to go there. So I wanted to start things off kind of like we left the last problem. What if we had an even split, so a pair of juniors and a pair of seniors? So again, I'm short on board space. Normally I'd like to write this out a bit more fully, but so now the bottom of our fraction is finally going to change. We're still picking out students from a group of 14. That part's not different, but now we're going to need 14C4 instead of 14C2. And up top, we technically need to make 2 separate choices. We've got to pick our juniors, we've got to pick our seniors, and each one of them we're drawing a pair out of the pack, so to speak. So to get our 2 juniors, there are 6 C2 ways we can do that. We actually did that exact calculation, for this part, in the previous problem. Similarly, there are 8 C2 ways we could pick out our seniors. Now, remember, our friend the fundamental counting principle says if we make 2 choices and we know the numbers for each of these guys, we combine them with, that's right, multiplication. So got a dot right there, linking the 2 of them up. So again, we did these calculations last time, so 6C2 was 15, 8C2 was 28. Again, feel free to confirm, that's fine. 14C4, as it turns out, when I worked that out, is 1001, which every time I do this, I feel like weird, like, want to make like some sort of Arabian Nights reference. So Scheherazade. Anyway, so when I work out 15 times 28, I got 420 up top over 1001. You can reduce the fraction down because, as it turns out, those guys are both divisible by 7. So you get 60 over 143. Okay, so breaking this in was kind of this bigger problem pool that we've got to worry about. Okay, the next example I want to take a look at, we kind of actually have to break up into chunks. So if you look at the PowerPoint slides, it says, how likely is it that we pick out a group that includes at least 3 seniors? So take a moment, process how that might be different. So we kind of have some different possibilities we're going to have to consider at this stage. So I'm going to leave my skeleton of the format kind of intact because a lot of this we can kind of reuse. But what I'm going to do before that, don't ask me why I put down the eraser when I knew I still need to erase stuff. Here's what I'm going to do first. So it said at least 3. Let's look at what happens for getting exactly 3 seniors. Okay, so now when I look through this, I only need to pick out a single junior at this point because we still need to fill out the group with somebody who's not a senior for that purpose. So I'm going to change that to 6C1. 6C1 is 6. If you've just written 6, I'm okay with that. Over here, now we're needing to pick out 3 seniors. Okay? So that's what we got so far. All right. Now, 6C1, we said is 6. 8C3, as it turns out, if you check, I got 56 when I worked that out. So there we go. And down below, 14C4 is still 1001. When I work out the arithmetic up top, I get 336 over 1001. And then that actually reduces down again. So I got 48 over 143. Okay, so that's exactly 3 seniors. That's not what we're after. Notice I'm not putting my magic I'm done box around this number. We got to dig in a little bit because at least 3 seniors, this is a possibility. We could also have a group that's entirely seniors, right? So I'm going to do that up here. So we've got kind of 2 separate cases. Exactly 3, all 4 of the people in the group being seniors. All right. So we've still got 14C4. living down below. But up top now, we don't need to worry about picking out juniors at all. We're only pulling seniors. So we have 8C4 living up top because we're picking out 4 seniors from the group of 8. Okay, so now when I work that out, I got 70 for 8C4. I got 1,001 again, down below. I only did this once. I just keep copying it. I'm totally fine with that. All right, so that ends up reducing down yet again to 10 over 143. All right. Now you might be asking yourself at this point, self, what do I do with these two separate calculations now? You might be inclined to try to multiply them together because it seems like that's like a counting principle kind of thing. We're multiplying stuff, right? Hold on just a bit. Yeah, put on the brakes. As it turns out, we don't want to multiply these together. Drawing back on what we talked about in that last section, this is exactly 3 seniors. This is all 4 seniors. Can those things happen at the same time? No, they can't. If we pick out exactly 3 seniors, we can't pick out all 4 seniors. So what we need to do here is use the fact that these are mutually exclusive. And remember, when we have mutually exclusive events and we want to know whether one or the other happens, we add the probabilities instead of multiply. So now I'm going to leave that 48 over 143 down there where we can see it. So we take this guy that we got for exactly 3, add him to this guy that everybody is a senior in our group. And we have the total probability of 58 over 143, or the appropriate decimal if you went that route, that we pick out a group that has at least 3 seniors. So keep that in mind. I'm actually planning on posting an extra worksheet because dealing with this at least scenario is kind of important, and it often trips people up. So a little more practice is not a bad thing. Technically, this isn't the only way you could go about it. If you take some more advanced probability and statistics type courses, there are other ways you might try getting at an at least type scenario than this. But for the purposes of this course, this is the way I think we should handle it. All right, I want to take a look at one last set of examples before we pull the curtain closed on probability and counting. So stay tuned.